Amatya, the session is, you can start the session. You can explain what is legendary and Jacobi symbol.
Thank you, sir. Okay, I'll start with the session. I'll just present my screen. I hope the screen is visible to everyone.
Yes, it is visible.
So before I proceed, there is one doubt that is likely to have occurred while explaining the prerequisites. That is, like for example, I taken n is equal to 7, and when n was 7, we took the values 1, 2, 3, 4, 5, and 6. So why we took these values is basically these values are from 1 to n minus 1, that is 1 to 6, and basically these values are they are co-primes. They are they are relatively prime to the 7, that is our n over here that we took. So basically GCD of any number that we are taking, the GCD of any number that we are taking, comma 7. Okay, it should be equal to 1. That is the basic the basic thing that we'll be considering. That is why if you take GCD of 1, suppose 1 and 7, it is the value that you get is 1. GCD of 2 and 7. Since 7 is the prime, so all numbers are coming directly from 1 to 6. And in the second example that we are taken,
Amatya, I had one more doubt over here. I just want to ask you that when you
yes,
are finding this is fine. We do 1 comma 7, 2 comma 7 because they are relatively prime to each other. So GCD of any number comma 7, which is n, should be equal to 1. So the your all the values will lie from 1 to n minus 1. That is true.
1 to n minus.
But how do you declare the values as they are 1 to 4 are the quadratic residue of
Yes,
7 and 3, 5?
yes, sir. Yes, sir. So I'll just explain it again
Yeah.
over here. So basically, like we took the values from 1 to 6 over here on left hand side, but
Hmm.
to find that which of the following are quadratic residues, what we do is we check the right hand side. Over
Yeah.
here, what are the unique values that you get? Unique values are 1, 4, and 2. Okay, and
Yeah.
rest others that we are solving is basically they are repeating 2, 4, and 1. So
Yeah.
unique values that you are getting are basically 1, 2, and 4. So these numbers will be our quadratic residues, and the remaining one. So 1 we have taken already, 2 we have taken, and 4 we have taken. Remaining you have 3, 5, and 6. So
Okay. Got it.
these are quadratic
Got it.
non-residues.
Got it. Got it. Got it. Thank you. Yes. Yeah.
Yes. And like rest of the thing is explained in video. Plus, we take if the example as n is equal to 8, when we were taking n is equal to 8, uh, there is a possibility that people will ask that why we didn't take 2, 4, and 6 over here. So 2, 4, and 6 are not relatively prime to 8. Since you'll get the common factor, the when you find out the GCD, you may get the GCD as 2. If you take 4 and 8, the GCD will be 4, and 6 and 8 again it will be 2. It's not 1. So you always have to check that the numbers which you're taking, like 1, 3, 5, and 7, if you take the GCD of these numbers with 8, you'll always get the GCD as 1. So this was one thing that we could have cleared in the prerequisite. And now I'll proceed with the video explanation for. So we'll be having basically two videos. One is on the algorithm and one is on the types of numerical that are asked in exam. And here is the Solovay Stresen algorithm. Today, so the audio is audible for the video.
We can hear you. You can just start again.
Sir, it is audible for the video. The audio.
No, no, no. Video is not audible. What you do know, Amatya, what you have done now, what you have shared this screen or you have shared the tab. Try to share the tab and check if it is possible.
Okay, sir, I'll do so.
Because usually what happens now, usually if you uploaded the video on either your Google Drive or on the YouTube, we are able to, when we share the tab, we are able to hear the video. You can just play it again. Let's see if
Sir,
it will
this one is saved in my local computer. Like I have uploaded it on YouTube also, but this one is saved only in the computer, which I'm sharing right now.
okay. Just check whether we are able to, we are not able to hear.
Sir, I'll play it like for some time, and if
Yeah,
it is not audible, someone can write it in the chat.
okay, okay.
I'll check then. Today, we will be proceeding with the algorithm for Solovay Stresen.
Audible,
So
audible.
before we proceed with the, it's audible, sir.
Yes, it's audible. It's audible. Yes.
Okay, sir.
Yeah.
Solovay Stresen algorithm. If you have not watched the videos on the prerequisites, that is the quadratic residue and the legendary number and Jacobi numbers, then I will request you to watch those videos and then proceed with this video to understand, to get a better understanding of Solvay-Churchin algorithm. So in this video, so let's proceed with step one of the Solvay-Churchin algorithm. If you're not given a value of a, you can choose any random integer a such that 1 is less than equal to a is less than equal to n minus 1, where a is nothing but our integer and n is an odd integer. Now we'll be doing the primality testing for n. So basically, primality testing is done to determine whether n is a prime number or a composite number. Any even number except for 2 is is basically a composite number because it is divisible by 2 also. So that is why we consider this as only for odd integers. And coming to step 2 we take the value of x as a upon n. This is nothing but a legendary symbol. That is assuming n is prime. So it could be Jacobi as well if n is composite. So we take the value of x as a upon n. Now if x is 0, then we return n is composite. X, is, x comes out to be 0 if a is divisible by n. And in step 2.2, the second part of the step 2, what we do is we associate the value of y as, we assign the value of y as a raised to the power n minus 1 upon 2 into modulo n. And going to step 3 is if x is congruent to y modulo n, then n may be prime. So you need to note the word that it may be prime. It is not necessarily prime. But if x is not congruent to y mod n, that is if this condition that we wrote before fails to satisfy, then we can definitely for sure we can say that else n is composite. So indirectly, this this algorithm that we'll be using is used to tell that the number is composite or not. If not composite, it may be prime. It does not guarantee that a number is prime. Maybe prime. And as discussed before, so we can write the above in short that in case P is found to be prime, it will become a legendary symbol that is A upon P, and it will give the value 0 plus 1 minus 1, and it will always be in this range, that is 0 if you get when P divides A, and 1 you get if A is a quadratic residue of modulo P, minus 1 you get if A is quadratic non-residue of modulo P, and P here denotes a prime number. Instead of P, you can also have the notation N. And coming to, so if that N were over there was composite, then it would have been a Jacobi. Instead of a legendary symbol, it would have been a Jacobi symbol. And that's what we have defined over here formally, that if A is not congruent to 0 modulo P and P is not a prime number, that is P is a composite number usually denoted by N. In that case, we don't denote it by P, we denote it by N. Then such that n can be broken down into products of distinct prime numbers raised to powers if necessary as follows. So n can be written as product of prime numbers. For example, n is equal to suppose n is equal to 15, you take the number 15. 15 can be written as 3 into 5. So you can write 15 indirectly as 15 is equal to 3 raised to 1 into 5 raised to 1. So these are your prime numbers, and n is equal to p1 raised to e1, p2 raised to e2, and so on up to pn raised to e3. And all this has been discussed before. So basically, you can break down your Jacobi symbol as product of summation of I is equal to 1 to k of your legendary symbols raised to ei. Okay, and this has been discussed in detail in the other videos. Now there are some exceptions to this. That is, for some numbers, even though we may satisfy the condition x is congruent to y modulo n, it turns out that the number is not prime. That is why we use the word maybe. Uh, we use this word may be prime. So that means if this condition is satisfied, if x is congruent to y modulo n, then it may be prime. And which are such numbers? One example of such number is, if you can see, it is 91. So, for example, consider the number 91. If you consider the number 91 and solve using the algorithm, then that number will be turning out. It will satisfy the conditions on both sides, and according to algorithm, you'll get it as a prime number. But we know that 91 is not a prime. So it turns out that the number is not prime. Such numbers are known as Euler's or Euler's, whatever you say, Euler's pseudo prime. So such numbers are known as Euler's pseudo prime numbers. And coming to, there are certain properties of legendary symbols that we need to note, and these properties are very important to solve our uh, problems related to Solovay Stressen's algorithm. So if n is a positive odd integer and m1 is congruent to m2 mod n, then m1 by n is congruent to m2 by n. We use this not very often, but this is also an important property. Some other important properties that are you come across very often is this one. This is very important. If n is a positive odd integer, then 2 upon n is equal to 1 if n is congruent to plus minus 1 or 3. Okay, so basically the trick over here that we are using is, if you get the if you get this as uh, the legendary symbol 2 upon n, if you get the legendary symbol in this form, you divide n by 8. If you are getting 2 on top, if you are getting the value of a as 2, what you do is you divide n by 8, and if you get plus or minus 1 as a remainder, then you can directly denote that this fraction is equal to 1. In other case, if you are getting 3, so it will be either 1 or plus minus 1 or plus minus 3 that you will be getting on dividing n by 8. So if you get plus minus 3, then you can directly denote 2 upon n as minus 1. So this is one trick involved over here for directly computing the value of 2 by n using the property. And another property is, if n is a positive odd integer, then m1 by m2 upon n will give you m1 by n into m2 by n. So it does not mean that you're multiplying n into n, you'll get n square. So this is one property of legendary symbols, that m1 upon n into m2 upon n can be split into m1 by n into m2 by n. So in particular, if m is equal to 2 raised to k into t and t is odd, then m upon n is equal to 2 upon n raised to k into multiplied by t upon n. So that was our property. Basically, you need to remember this part. This usually comes. And coming to the other part, suppose m and n are positive odd integers, then if m upon n is given to you, then what you can do is, you can take, basically this m should not be 2. if it is 2, then you can apply the previous property that we discussed before. But if it is not 2, it is some other number, some other positive odd integer, then what you can do is you can take as minus n upon m if m is congruent to n is congruent to 3 mod 4. So in this case, what you need to do is divide m by 4 and m by 4. And if you get the remainder as 3 in both cases, then you can switch this expression m upon n equal to minus n upon n with this. So this you can write as this expression minus n upon n. So m upon n. Else, if this condition is not satisfying, instead of 3, if you're getting any other number, even minus 3, any other number you get, so this will be n upon n. And basically, there is no change in the sign, only the fraction is reversed. The linear symbol, it is reversed. And this is our Solovay Stresen algorithm. We will be discussing the problems that are related to the Solovay Stresen algorithm in the upcoming video. Thank you.
I hope everybody has taken down the algorithm what is explained by Amatya. Have you solved any problem, Amatya?
Yes, yes, sir. I have solved the 3 problems that are given.
Okay, okay. So I hope everybody has noted down the algorithm. He has nicely explained the algorithm, the steps which are involved in legendary to solve the Solovay Stresen. Okay, how to check for x a by n. Then what is the value of y? When do we return it as a composite? Okay, followed by the properties of the what we have to take into consideration. Okay, so you can go forward to explain. Continue.
Yes,
Amatya.
yes, sir. In case if the this thing algorithms and all are not being noted, you can refer to the video which I'll be sharing after this lecture. And the algorithms that you should note for since we'll be using this while solving the problem is one is this one, and as I said in the video, it's very important. This one is one which we'll be using, and the other one which we'll be using in the numerical will be this one, the first part m1 by m2 upon n is equal to m1 by n into m2 by n. This is the first part that we'll be using, and third algorithm that we'll be using is this one. So for all the problems that we'll be solving, only using these 3 properties, we'll be able to solve the entire problem. So this, if you can make a note, everyone can make a note, then it will be helpful. And I'll proceed with the numericals. Let us discuss today some problems or numericals that you may encounter in your exam. Okay, so let's come to question number 1. These problems are related to the Solvay-Stresen algorithm. Okay, so coming to question number 1, suppose you are given n value as 13 and a is given as 2. Suppose a is not given, it is preferable to take the value of a as 2 since we already know that n is going to be an odd integer. So a positive odd integer. So definitely if you take the value of a as 2, then the GCD of a and n will always be equal to 1. In the question that was given, these two values were given to us in the question. That is n is equal to 13 and a is equal to 2. So now coming to the question. Now we are given n as, the value of n as 13 and the value of a as 2. So we need to test if n is composite or not using Solovay-Stresen algorithm. Here is our answer according to the algorithm. In the first step, we consider the value of a if not given. Since the value of a is already given, we write given a is equal to 2. Coming to step 2, we take the value of x as a upon n. So the value of x in this case would be A is 2 and n that we are given is 13. So A upon n will be 2 upon 13. Coming to the first part of step 2. Since GCD of 2 comma 13 is 1, that is the only common integer that divides both 2 and 13 is 1. Therefore, we can conclude that x is not equal to 0. Correct? And second part of our step 2 is basically y can be written as a raised to n minus 1 upon 2 into mod n multiplied by mod n. So y is equal to a is 2 raised to 13 minus 1 upon 2. This is our power n minus 1 upon 2 multiplied by modulo n, that is modulo 13. This is our RHS, and the value of x would be nothing but our LHS, that is 2 upon 13. In step 3, that is in this step, now what we need to do is we need to check the value of whether this value, this condition is satisfied, that is x is congruent to y mod n. Now we check this. So we first solve the left hand side. Solving the left hand side, if we take, we are given x is equal to a upon n is equal to 2 upon 13. Our trick over here was, like, according to the properties that we had studied before, the trick that we use for this case is that suppose we are given the value as 2 upon n, then we first divide n by 8. Same thing we are doing over here. We divide n is 13 by 8. If you multiply 8 into 1, you get 8 1 the 8, and the remainder that you get in this case is 5. But we are searching for remainders either plus minus 1 or plus minus 3. So 5 is of no use to us. So we ignore this. But this, if we modify this a bit, instead of 1, if we take 2, so we get 8 multiplied by 2 is 16. Basically, we took the next power. Since this was, we can even get minus 3. So instead of 1, we are taking 2. So we didn't get plus power of 1 or 3 over here. So we took the next power. From 1, instead of 1, we took 2. And 16 minus 13, you get remainder as minus 3. And minus 3 is of use to us. If you can see over here, if we get 13, n is congruent to plus minus 3. We have got minus 3 mod 8. So we can write this as this, the condition that we have obtained over here. We can write it as 13 is congruent to minus 3 mod 8, and it is of this form. N is congruent to minus 3 mod 8. Then we can write the fraction that we were looking before, that is the legendary number, can be given the value of minus 1. So the legendary number 2 upon 13, it may not be legendary number, but we are assuming it to be prime. We are doing the Primality testing, we are assuming the value of n to be prime, and hence we are using the properties of legendration rule. So 2 upon 13, the value we get on LHS is minus 1 over. Coming to the RHS, now in RHS, what we do is we take a raised to n minus 1 upon 2 mod n. So a raised to n minus 1 upon 2, n was 13, 13 minus 1 would be 12 by 2, that is 6, and 2 raised to 6 mod 13. The value of 2 raised to 6 is 64, and if you calculate the value for mod, you get, since 13 into 5 is 65, and 65 is one more than this, then remainder that you get on 60, subtracting 64 minus 65, you will get the remainder as minus 1. So you are getting RHS over here as minus 1, which is same, if you check, it is same as the LHS that we had obtained before. And hence, we can conclude using Solovay Stresen algorithm, since x, we can conclude that LHS is congruent to, is equal to RHS. So x, LHS was x and RHS was y mod n. Is x is congruent to y mod n. Therefore, by the Solovay Stresen algorithm, we can say 13 is a prime. And coming to our problem number 2. So this is our problem number 2. Suppose A n has a bigger value. Before we had taken n as 13, and which is a smaller value, we know by default 13 is prime. But for bigger value like 341, to find out whether this number is prime or not, we do the primality testing. Okay, so n is equal to 341, a is equal to 2. Now answer for this question would be, if we take step 1 as a is equal to 2, given, it's given in the question, so we don't need to assume the value. If it was not given, then it is easiest to assume a as 2. Coming to step 2, x is taken as a upon n. X is equal to, in this case, the value of a that is given to us is 2. The value of n that is given to us is 341, that is 341. So we write 2 upon 341 as the value of x. This is our LHS that we have obtained. Now coming to the first part of the step 2, that is GCD of 2 comma 341 is equal to 1, and since there is no factor in common except 1, therefore GCD of these two numbers is 1, implies x is not equal to 0. So we have checked our first condition, we proceed with the further conditions. Second part of the step 2 will become that y, you can associate, assign the value a raised to n minus 1 upon 2, a raised to n minus 1 upon 2 multiplied by modulo of n. So y will get the value 2 raised to n plus 341 minus 1 upon 2 and multiplied by mod of 341. And this value that we obtained is r. This is the RHS, correct? And coming to step 3 is finally to check this Solovay Stresen algorithm condition. That is, if x is congruent to y mod n or not. Now we solve the LHS first. That is the value for x. X we had got as 2 upon 341. Same way, since it is of the form 2 upon n, as I told, this property is very important. It comes very often. So we use the same property and we get the value as, we have to basically divide n by 8. Same thing we are doing over here. N over here is 341. So dividing n by 8, we get 8 multiplied by 42 would give us 336, and remainder that you're getting on subtracting these two numbers is 5. 5 is of again no use, since we need plus minus 1 or plus minus 3. So we ignore this. It is of no use. Just take one number ahead of this. So you are getting a positive number over here. Maybe you may not get a plus 1 or plus 3. You may get a minus 1 or minus 3. To check that, you take one number ahead. Instead of 42, you take 43, the next number. Now checking the next number, 8 into 43, you will get the value as 344. If you subtract these two numbers, the answer will be a negative number, that is negative 3. And negative 3 is of very much use to us, as n is congruent to plus minus 3. And since they are congruent, what we do over here is minus 1. If n is congruent to, the value of this fraction will become, of the legendary symbol would become minus 1, since we are in this form. That is 341. N is congruent to minus 3 mod 8. Now what we do is we substitute the entire value of the legendary symbol as minus 1 over. Suppose we would have got plus or minus 1 over here instead of 3, then we would have substituted this value as 1. And this is how we solved our LHS. Proceeding further with RHS. So for RHS, we had the value a raised to n minus 1 upon 2 into modulo of n. So 2 was our a raised to 341 minus 2, 341 minus 1 upon 2. This would give us the value 170. And 2 raised to 170 mod 341. This is the value. Now 2 raised to 170 again is a large number, so 170 we can split into 128 plus 32 plus 8 plus 2. And you can write it as 2 raised to 170 can be written as 2 raised to 128 plus 2 raised to 128 plus 32 plus 8 plus 2. Basically 2 raised to 128 into 2 raised to 32 into 2 raised to 8 into 2 raised to 2. So this is how you can split it up. So 170 can be split up into these small numbers. That's what we have. Now we'll calculate only these smaller value from these smaller values. And we wrote that over here 2 raised to 4, 2 raised to 2, 2 raised to 4, 2 raised to 8, 2 raised to 16, 2 raised to 32, 34, and 128. And we find its modulus with respect to 341. So 4 mod 341 is 4. 2 raised to 4 would be basically 4 square mod 341, and you get the value as 16. 2 raised to 8 mod 341 would be 16 square mod 341. When calculating, you will get the value as 256. 2 raised to 16 mod 341 would be 256
Amatya,
square
you can just skip this part
mod
because we have already done
341.
this. You can go to the,
Yes,
this calculation is easier. Just pause it and skip it. Okay, we have all done it so many times. Yeah.
so on solving that, finally you get the value as 1 into 1 mod 34. Answer will be 1. And I'll continue. So you're getting RHS as 1, but LHS that we were getting before. So LHS that we were getting before was not 1, it was minus 1. So there's a difference over here. LHS and RHS are not equal. Hence, X is not congruent to Y mod N. Okay, so we can conclude X is not congruent to Y mod N. So the condition is not satisfied. This, therefore, this implies that 341 is a composite number. Our N that we took is a composite number using Solovay Stresen algorithm. Correct? And also to check, if you want to check, 341 is not prime. Its factors are 11 and 31. 11 into 31 is 341. And 340, 341 is a composite number. Going to our last, so the answer we obtained before is correct. Like that we can check if we know the factors. Then final problem that we'll take into consideration for n is equal to 287 and a is equal to 10. These are the values that are given to us. Suppose that these two are the values given to us. Now you see a is not 2 anymore. So now this problem is a bit trickier since it is not just 2, it's not the basic value. So you take answer will be step 1 given a is 10. Step 2, what you do is write it as a upon. These steps remain same. We'll proceed a bit faster now. Since x is given as a upon n. So x is equal to the value of a is 10, value of n is 287. So x is equal to a upon n, that is 10 upon 287. That is what we get. And one thing that you should note over here is since 10 has the factors 2 and 5, and none of it is divisible by 287, you can directly say that PCD of 10 and 287 is equal to 1. Therefore, x that we have to check whether it is 0 or not, we can conclude it is not equal to 0 since GCD is 1. The only factor that they have in common is 1. So why you have a raised to n minus 1 by 2 into modulo of n, that is a value is 10, 287 minus 1 by 2, same steps, and you get LHS is this, RHS expression is this. Now we have to check if both are equal or not. Okay. So same condition, we have to check whether it is equal or not. LHS is equal to x is equal to 10 upon 287. Now 10 can be split up to this. How? I'll tell you. This is one of the properties that we have discussed before. So if you remember, now 10 basically I can write as 2 multiplied by 5. So m1 into m2, where m1 is 2, m2 is 5, n is our 287. Now, if the Legendre symbol is of the form m1 into m2 upon n, we can write it as m1 upon n into m2 upon n. Okay, this is the split up that we get according to properties of Legendre. Now, once we've got this split up, we write the same thing. 2 into 5 upon 287 can be written as 2 upon 287 multiplied by 5 upon 287. This does not mean 287 square. This is just a property of Legendre symbol. Okay. We solve this separately. Okay. So 2 upon 287 can be solved easily upon using this 2 upon n methodology that the property that we used before, that is dividing n by 8. So when we divide n by 8, 287 divided by 8, we multiply 8 with 36, we get value as 288. Subtracting both, we get remainder as minus 2. So basically, we get 287 is equal to minus 1 mod 8. So 2 upon 287 would be equal to 1. Using this, since we have got this, we have obtained this expression, n is congruent to minus 1 mod 8. So we get the value of the fraction as 1. Okay. And that's how we solve this part. Now to solve this part, since we've always been solving, till now we have been solving this part, we now concentrate upon 5 upon 287. Now this is no more in this property. For solving this, we require our last and final property that we had discussed, that is this, of the form m upon n, where m is not 2. Okay, so if m is not 2, then we use this. Now in this case, m is 5, and both m and n are positive odd 80. Both 5 and 287 are positive odd 80. In this case, what we do is we take a mod with 4, that is n divided by 4, we check the remainder, whether it is 3 or not. So we are dividing 287 by 4. Okay, both m and n, both m and n, both the numbers 5 and 287, you have to divide by 4 and check. For both, you should get remainder as 3. As you see, on dividing 287 by 4, you are getting the remainder as 3. But on dividing 5 by 4, you are getting the remainder as 1. So both these are not equal. We can write this also. We can also write this as 287 is congruent to 3 mod 4, and 5 is congruent to 1 mod 4. So since both are not equal, there will be no change. That is, no change in sign. So m by n, we can write it as, we come under this category. Since both are not free, we come under otherwise. We write it as m by n. We write it as n by n. So we write 5 by 287 as 287 by 5. So that's what we wrote. And you see, we had got the value 1 over here and 287 by 5 over here. So 1 into 287 by 5 can also be written as 2 upon 5. Why 2 upon 5? Because again, 5, 285 would be a multiple of 5. If you subtract 287 minus 285, you get the remainder as 2. It could have, it cannot be solved further since 2 is not a this one residue of 5. So which we have discussed before. So it is not a quadratic residue of 5 according to the conditions that we have discussed before. Now that you can solve and check. So hence we conclude that in the second part we can start solving with the RHS. RHS is basically same similar way of solving. A a raised to n minus 1 by 2, 10 raised to 287 minus 1 by 2 into modulo 287. That is n, value of n. You will get 10 raised to 1. We'll get 10 raised to 143 over here, and same way like how we have been taught before, we can solve it 10 raised to 143 by splitting up, and we'll get the answer as 180 over here in the end. And if the condition is not satisfied, hence 280. In LHS we got 2 by 5, RHS we got it as 180, so LHS is not equal to RHS, hence 287 is a composite number. Using Solovay Stresen conversion, we can check it because 287 can be written as 7 into 41, so that is not a composite number. With that we end the video.
Amatya very nicely explained three examples. Yeah, I had sent you those examples for reference, but it was so kind of you to explain all the three examples. Okay, one with a smaller number 13, then we you explained about 287. Okay, and also about the second problem which I have given. Okay, so I hope students have understood the concept. Okay, so basically you need to keep those three properties in your mind. Okay, so how to go about when we solve with our LHS and RHS. Okay, And quadratic residue is also important because in the last problem, see, we have derived 287 by 2 as 5 by 2 using the quadratic residue uh, thing. Okay, so those three properties are very much important. Okay, followed by you have to find out your first step. Number one is basically your value of a, which is always provided to you in the problem. If it is not provided, as told by Amatya, you have to take the value as 2, because 2 with any value, your GCD will always come as 1. Okay, then you have to solve the value of x and y. X is a by n, and y is nothing but a raised to n minus 1 divided by 2 mod of 13. Okay, and then you have to solve your left hand side and your right hand side. Okay, you need to check for x is congruent to y mod n. Now when you're checking for x is congruent to y mod n, you have to solve your left hand side. So using the, when you're solving the left hand side, you require the property. Okay, that is property number 1, property number 2, and property number 3. Okay, so property number 3 will be used only if your n value, a value is anything apart from 2. Okay, if a value is anything apart from 2, then you have to use the property third property. Okay, and solve. If it is 2, then you can use property number 1 and property number 2 to find out what is your LHS and RHS. If your LHS is equal to RHS, that means your number is a prime number. If your LHS is not equal to RHS after solving, that means your number is a composite number. So basically, this algorithm will tell you whether the number is a prime number or a composite number. It's a short algorithm which tells you whether it's a prime number or a composite number. Okay, now all three problems which are solved by Amatya had come in the question paper. Okay, so these are all three questions which were repeated in your question paper. Okay, so there is a probability in two of your questions paper they had asked these problems. Okay, so there is a probability that you will get a question on Solovay Stresen primality testing. Okay, so I request Amatya to please upload the two videos which you have shown us today. Okay, that is the algorithm and also the problem solving. Okay, so please upload it on YouTube and send me both the link of the YouTube of the video. I will put it in the class. Okay, and share it with all the students so they also know how to go about with your Solovay stress and primality testing. Is it okay, Amatya?
Yes, sir. Sure. And sir,
And
one last thing I wanted to show, if it is possible, like it will be 2 minutes.
yeah, go ahead. Yeah.
I hope the screen is visible.
Yes, yes.
So, like I was saying in the video, this part was there where we said that we got 2 by 5, and since 2 was not a, it was a quadratic non-residue of 5, that is why we left it as it is. So why we need to check if it is a quadratic residue or not is basically, suppose we would have got, instead of 2 by 5, instead of 2 by 5 we would have got something like 1 upon 5. Okay, so 1 upon 5 is basically, if you check 1 square, just for 1 I'll show, like 1 square if you see is congruent to 1 mod mod 5. This is using the quadratic residue concept, the one which I showed in the video. So you are getting 1 on the 1 as the value of a. So you can confirm that 1 is a quadratic residue. Actually, 1 is a quadratic residue for almost every number. Since 1 minus 1 will be 0, and 0 divided by any number will give you uh, remainder as 0. So you can say if it is 1 upon 5, this expression could have been written as 1 directly over here using the properties. So since we got 2 upon 5 instead of 1, we got 2 upon 5. 2 is not a quadratic residue, that can be checked. And since it is not a quadratic residue, we leave this this symbol as it is. We leave it as 2 upon 5. If it would have been 1 upon 5, we could have written it as 1 only and then checked with 1. If we are getting 1 on the RHS as well, then we could have said it is equal. Thank you.
Yes, thank you, Amatya. It was a very nice explanation. Okay, thank you very much for taking so much of effort to explain this concept of primality testing. I open the forum to the students. If you all have any difficulties, you can put forth the difficulties and ask the difficulties, or you can go through the video once again. Okay, you can go through the video once again because you need to solve. Say, while the video was going on, I have solved all the three problems, and the concept is quite clear for me at least. Okay, so I want you all, if you have not solved it, please solve the please don't leave the chat. Okay, please don't leave the class. I have not told that the class is over. Okay, so please solve the problem. Okay, I will shortly send you the link of the video in the classroom. The previous two videos also, which were shared as a prerequisite for your today's class, as well as today's two video, which has been explained by Amatya. I will share it in shortly with you all. Okay, so if any of you have any difficulties, please ask. Let us see if I and Amatya can solve the issues, whatever problems you are having. Anybody having any difficulties in today's concept that was covered? There is still 10 minutes remaining. Okay, so you all can ask. Asta, do you have any difficulty? Asta? Okay, what about Anjali? Anjali Barad, any difficulty? Okay, Len, do you have any difficulties? Len Dias, any difficulties? Okay, good. Melroy? Melroy? Ruchika?
Yes, sir.
Melroy, any difficulties?
Sir, if the value of A is equal to 8, and when we are finding the LHS, so we have to keep on dividing it
Which problem you're talking
like
about? Which problem
two
you're talking
digits.
about?
So I'm telling about A is equal to
Ah,
value of A.
value of A. Yeah.
If value of A
Yeah.
is equal to 8, uh, then when we are finding the
Yeah.
LHS, so we keep on dividing
See, first of all, Melroy,
each.
your question is correct. I will just rectify before you go further. How do you take the value of A? Do you know what is the criteria how to take the value of A? What is why? See, n value will be given to you, right? We have to just find out whether that n that is provided to you is prime number or not. But while choosing A, what is the criteria of choosing? Usually, A value is given to you, but what is the criteria of choosing that A? No,
Two.
no. What is the criteria? Now, there in some problem it was 10. So, what is the criteria? How do we choose this value A?
Uh, we should get GCD is
GCD
equal
of
to
both
1.
the numbers should be equal to 1. So now when you are giving me an example of 8, okay, now 8 and the GCD, okay, and the number n, whichever is there, first of all, you have to check whether the GCD is equal to 1. Okay, if it is not equal to 1, that means it is a wrong problem. Okay, now if it is 8 is given to you, if a value 8 is given to you, GCD is 8. Okay, now you can ask me your question. I will answer your question. What was your question? If your A value is 8, then
So when we are finding LHS,
okay,
for that, uh, when we have taken A is equal to 10, we have taken 2 and 5.
correct.
So we take 4 twos
Ah.
for this one.
Okay, now if it is 8, no, what will happen? First of all, you have to, dividing the number into two prime numbers. Okay, now your 10 was divided into 2 and 5. Okay, both of them are prime. Okay, so what we will do is, if it is 8, what are you going to do? So you are going to say 2 4s are 8, 2 2s are 4, 2 4s are again 2 2 1s are 2. Okay, so what will be your factors? 2 2 and 2. Okay, so usually how you are going to do? So are you getting any? Okay, one factor you are getting is 2, but the second factor is 4. Okay, now 4, usually those two numbers should be the prime numbers. Okay, whenever you're taking those two, no, now how he has divided into 2, like for example 5 into 5 divided by 287 and 2 divided by 287, and both of them are prime. So A value will never be given to you as 8. Okay, A value will never be given to you as state. A value will be given to you in such a way that when you divide that number, okay, when you try to find out the factors of those number, the both factors, okay, or either two factors or three factors, okay, those factors will be always a prime factors. Okay, so those value will be given to you. Is it clear, Melroy?
Yes, sir. Thank you.
Yeah. Anybody else? Please don't wait that I will take your name and you will ask me questions. Please ask the questions. This forum is open to all. Okay. Nidhi, are you having any difficulties? Sheena? Okay. Swini? What about Swini?
Mhm.
Okay. Shweta?
Excuse me, sir.
Yeah, yeah.
Sir, on the doubt
Yeah,
that he asked, I
yeah.
would like to show something, like, if
Okay,
possible.
fine. No issues. No issues. Go ahead. If the rectify, if I'm wrong, please rectify me. Go ahead.
No, sir. Sir, it was correct.
Yeah.
In fact, what you said was exactly correct. But only thing is that you can see it in the properties, the one which we have mentioned. So there is this property that we have also mentioned. That suppose if, as you said, eight. Suppose you are given eight. First thing, there's a very less possibility, as I said, that you'll get eight since it is divisible by two. Okay, you won't get two on top. If you get a number like that, eight. Why you won't get eight is the first reason that you won't get eight for primality testing is basically that this number is even, and you know it is not going to be prime. It is divisible by two. So even numbers you won't get. But for what I was saying is, suppose you are given a number which is recurring, which has recurring factors like, say, 2 into 5 square. Maybe you are getting the number 50. 50 also you won't get. So basically, that case is not possible. Maybe you got just 5 square. Let's say the number below it was 25, an odd number. It is always a odd positive integer. Suppose you would have got 5 square upon 25 if you are taking this as a number. Then these cases rarely occur, but if it occurs, then you have to take into consideration this property which was given. Whatever power you are getting, the the legendary symbol raised to k. So that value will get. But it's like not possible because again in this case also, if you see, five will be divisible by it divides 25. 25 is divisible by 5. So such cases are not actually possible. If you get powers, if you are talking about powers, then you must consider this as the formula, 2 upon n raised to k. Whatever power you are getting, the legendary symbol raised to the power k, and then same property. Then you revert back to this property. So it's almost similar.
Okay. I think Melroy might have cleared his doubt. Okay. So if anybody else is having any difficulty, please ask right, right here. Okay. So there are few instructions. Okay. If you all have, please interrupt me. Okay. Now I have shown I have already sent you the names and the roll numbers of those students who have constantly not submitted the tutorials. Okay. I don't want to point out to anybody's name. I had told students to please be today here. Okay. There are some students who have constant. Okay. I can understand about tutorial 6 and 7, but I have ignored tutorial 1 and 2. I have started from 3, 4, 5, and 6 and 7. There are some students who have constantly not submitted the tutorial. I am closing the link today at 7 o'clock in the tomorrow at 7 o'clock in the evening of all the forms. Okay, none of the forms will be accepting the responses. Nikhil is there here. Nikhil is present. I have given you lot many chances. Nikhil is present. Nikhil is not there here. He was there for the class. He has left. Elroy is there. Elroy. Elroy, can you tell me why you have not
Yeah,
submitted
I'm there, sir.
tutorials? What is the reason?
So I gave it yesterday, sir. So I submitted.
Submitted. So you should have replied on the group, no, that you have submitted the tutorial.
Yes, sir.
Okay,
So
no
sorry.
issues. Jorel is there. Jorel. Jorel is not there here. Saish is there. Saish, who is roll number 39? Can anybody tell me who is roll number 39? Who is roll number 39? Shivam has also not submitted. He's not turning up to the classes also. At least Elroy sits for the classes. Okay, Jorol was there. Nikhil also doesn't attend my classes. Siddhant is there here. I have not seen Siddhant attending classes. He has not submitted so many. Noshin is present. Noshin. Noshin is also not there. Ashwini is also not there in the chat. So those students have not submitted, and the strict action will be taken against them as the numbers are going to HOD, and further actions will be taken, and the actions will be taken also on their attendance. Okay, these are the students who are constantly not attending the. There are many other students also, but they have made a point that they are submitting the tutorials. Okay, so those who have submitted the tutorials yesterday, after my yesterday's message, please message me on WhatsApp. Okay, on the group only, on the cryptography group only, so that I can mark, I can check and I can mark the student that they have submitted the tutorials. Okay, so all 7 tutorials, that is one thing. Second thing is, as I have also already told about IT 2, portion will be AES, Advanced Encryption Standard, and Unit 4. Okay, so your IT is on 16th. Okay, I request all of you all to answer the IT. It will be very good for you all to, for your mock exam, which is there on 21st. Okay, it will be a 60 marks paper, similar to your final exam. Final exam will be of 100 marks. So I'm setting a 60 marks paper, similar lines of your final exam. Okay, which will include all Unit 1, Unit 2, Unit 3, Unit 4. It is on 21st of this month. Okay, 21st of this month, which is a Monday. After your ITs, next week, Monday. Okay, so I have already closed down the course exit survey of 62 students. 2 students had not given the course exit survey. So I'll see who are those students who have not given the course exit survey. And for tomorrow's class, please don't miss my tomorrow's class. I'm not going to teach you all anything. Tomorrow's class will be any difficulties if you have in any of the problems. Okay, whatever problems that you have done from Unit 1, Unit 2, Unit 3, Unit 4, we will solve the difficulties. Okay, and I will mark the portion for okay, also the question bank which has been submitted to you all, if you solve at least 2 to 3 questions per day, you will be able to come out with some difficulties which I'll be able to solve. Okay, so please refer the question bank. Okay, most of the question, 95% of the questions which are there in the question paper, okay, it will be present in the question bank. Okay, we have collected the question bank collectively from all the question papers and also from textbooks and everything. Okay, so that is all I wanted to tell. Okay, so please submit your tutorials by tomorrow 7 o'clock. Okay, and course exit survey is already, I have closed the link for accepting the forms. Okay, so thank you very much once again, Amatya. Very nice work done. Okay, thanks a lot for explaining the Solovay Stresen primality testing in a very perfect way. I hope all of you have understood it. Please solve it again. I have already uploaded the videos on the classroom. Okay, and the classroom is already, you will already get a notification. There are altogether 4 videos, 2 videos about the prerequisite, and the 2 videos which Amatya has told, the algorithm, and 3 problems what he has solved. Okay, so please go through it. It's a very important concept with respect to your examination. Okay, so please solve those properly. Okay, thank you very much.